All right, continue.
Okay, so you can choose to download the notebook and set up your local environment like what I did. And also you can also choose directly running it on the CoLab, and CoLab is provided by Google. You just need to log in with your Google account, and it is in cloud environment, and all of these libraries are already set up for this experiment. And first of all, like these are the setup, all the libraries we need to run this tutorial. Most of them are just ordinary Python libraries. And one thing we need to pay attention is that we require TensorFlow 2.4. You can it takes a little time to load. Yeah. This is the latest version we are using because we in this tutorial we release on some API that only provided by the latest version. So if you are use an previous version, you may need to customize some pre-processing by yourself. So the convenient way is just to download this version. And let's load all of these libraries. And next, I will show you the Word2Vec training and step by step. And this tutorial basically covers a couple of steps what we need to do. And the first step is data preparation. You know that first we need a text corpus to train the Word2Vec, and so we need to process this text corpus to extract some input for the neural network. And here are two techniques, negative sampling and step sampling, which are designed for Word2Vec. Basically, they are designed to improve the efficiency as well as the embedding quality. And we will see how these two sampling techniques work later. And next, after we get the data processed, we need to implement a Word2Vec model, which is just a neural network. And after we have these two things, we can just feed these data in the neural network and train it. And the training just means, you know, two process. One is the forward propagation to calculate output from the input, and then the backward propagation to update all the weight to train the model. It means, you know, we optimize the weight of the neural network. So here, first of all, the step is that we need to get a text corpus to train the model. And here is a online resources. We can just download it. And the default location is in, you know, this is the default location. You can find it here. We can check about this file, Shakespeare. Can you see my screen? Check about what it looks like. And it is something like this kind of sentences. All of them are just a text. And the size of that one is not very large, just around 1 megabyte. So this is only for the purpose of demonstration. So if you want to train a really good Word2Vec, these vectors, you may need a much larger text corpus. So here, you can also just print some information of these lines within this file. Here we print the first 20 lines just like that. And next we just release on.
So how about we just remember to periodically to see if I have any questions with people following. Yeah. Any questions so far?
Sorry, can you go up a little bit? How did you print them out again? I missed that.
You mean the print? We just, okay. Yeah, just open it and read it line by line, and we only output, you know, the first 20 lines to see what's the contents in this file.
Yeah, okay, got it. Thank you.
Yeah. So the next is that we need to load all of this content into an API TensorFlow provided called dataset. And here we just use this API and to feed this location of the file in this API so that we can create a text dataset. And you can check the type of the text data set, which is a filter data set. And the purpose we use this API instead of like customizing by ourselves is that this kind of API is provided by TensorFlow has some built-in design to, to deal with some really large data sets. It has some speed up designs, which makes you to process it very efficiently. So here, actually, we can also, when we load all of this text content, we can specify some filter conditions. And here, the conditions is just if this line is empty, so the length is 0, so we just skip this line. So we can check the content of the text data set by transfer it as a list. Like that, you can call the as NumPy iterator, and so that it can be transferred into a list, and we can check like the size of the entire data set. The size it still take a few minutes. Oh, sorry, a few seconds, I guess. Little slow. I found it is slower than when I try it. So I don't know why. So basically, we have like around 30,000 elements in this data set, and each one is a sentence. Each one is one row from this text corpus here. We just output the first five elements to see what it looks like. And the next is that what we need to do is to transfer it to, we first need to build a vocabulary. So the first thing is that there are some punctuators. We need to remove all of these things and only keep the word here, and then we need to build a vocabulary, like how many words, and to index this vocabulary, so that here we first define a function which just the first lowercase all of the data and also remove all the punctuators. And we just need to use another powerful API TensorFlow offers to us, which called text vectorization. And the text vectorization is just what we said. It will first apply some mappings. These are remove these kind of things, and then build a vocabulary and index this vocabulary, and also replace this word by its index. We can see how it works. First, we just got an vectorized layer instance, and then what we need to do is just to feed this text data set to this layer by the API by the method called adapt. And here we need to call the batch, because sometimes when we are dealing with a really large data set, it may run out of the memory, so that this will allow the data set to be fed like one batch after one batch, like that. So you can run here, and after processing this command, this line, we actually already get the vocabularies inside this layer, and we can get the vocabulary by the get vocabulary method calling here. And let's print some of the contents of the vocabulary. The vocabulary length is around 4 4,000, and these are the elements of what inside the vocabulary. These are just these words, and there is a special token, which means unknown, and this one is just to it designed for you to deal with some out of vocabulary problem that if the model meets a word that is never seen before. And after you get the vocabulary, you can just get the data sets in the integer form like that. And this line, it just leverage these data sets, the text data sets, and also this layer again, and to transfer it into the vector data sets. Let's see what the content in this data set. We can still use the SAN API as NumPy iterator to transfer the data sets as a list and check the content of the list. Do you have any question until now about what we did? No. So yeah, you can see here the number are the same because these sequences are just the integer version of this sentence. This is the original version in the text data set, and this one is the integer version of each sentence. So until here, we just get the data set. And the next step is that we need to extract the training samples from these sequences. And the training samples just means the input and output for neural network, these kind of cases. Next, we will show you, we will dive into what happened to this sequence by an example. The example is here. This example is what I copy and paste from this Shakespeare text data set. This is just one sentence here, and we just did the same before what we did, just to lowercase it and also to transfer it as some numbers. Here, I want to mention that for this step, we just generate a dictionary format of vocabulary, and this is just for speed. Sometimes if you use the list version, it will takes too long time to look up an element. So here you can see this sentence is transferred into the integer format, the same as what we had before. And next, what we did is just, to using a sliding window and to extract the neighbors for every word. For example, if the target word we want to train embedding is this one, and we just use a sliding window, we specify the window size as 2. You can specify other values if you like, and we will extract some we currently call it positive skip grams here. Take this example, like in total there are 42 pairs, and each pair is just like you can see 3 and 231, and the first one 3 is we call it a target word. This one is what we want to get embedding for it, and the second one we call it contact word. It is one of its neighbors, because that this 1 2 3 1 is a neighbor of 3, and also that one 102 it has a neighbor here, the 496, because the size is 2, window size is 2. So this step we just got to extract all the pairs here for training the neural network. And until now, do you have any question?
Any questions, anyone? And I think try to follow right now. And so, but if it's we are going too fast, and say, Gunnar, go ahead.
Yes, I just have a question. Just going back on some of the other cells in particular, for the function lambda, and this is just me, and
you mean
trying to go up to the cell with lambda. trying to figure
one.
out. Yeah, that one. A data set. Okay, data set lambda cast. Okay, wait. I just need some clarification on that part. What type of function would, because I'm just going back on the reading previously, could you remind me of what function that is a part of? I'm sorry.
You mean like what function or what?
Like what is this for? Like in general, with
yes,
high
exactly.
level.
I understand. Yeah, because I understand we're converting strings all the way to vectors. That's a general aspect. What about that specific cell?
That are just to remove these empty lines. You know, the X is
element.
Each element is a line, and if its length is, you know, if there is false, it means this line is empty. So we just remove it.
Got it. Makes sense. Okay, yeah, thank you.
Any other questions? Feel free to interrupt and jump in. Okay, all right, thank you.
I have one question.
Yeah, go ahead.
So far you've now converted all of the words and sentences into the vectors, right?
Yeah.
There's still no correlation between them. This is just preparing the data, right?
Yeah, these are all data preparation.
Okay, all right.
Yeah, and these are the pairs we use to train a neural network, and we call it Word2Vec neural network. Basically a 3-layer neural network, and you know, the embedding vector is actually the weight. A weight matrix of the first layer. So here I want to introduce another technique we call the negative sampling, which is our next step. It is still for the data preparation. So what is next?
To confirm, if you don't mind, these pairs right here are grouped like this based on their proximity, right? Because this one is right after this one. Isn't that right? In the sentence itself, like in the sentence, like for example, give him there or report him. These are like next to each other, like after or before.
Yeah.
That's how they're grouped like this, and the TensorFlow or the tool itself, the Word2Vec, does that automatically.
Yeah.
I don't do it. Okay.
Yes.
Okay.
And basically what we need after we get this kind of pairs, what we need is the first pair, the first element, the target word is the input, and the contact word is the label. So we use the J as input and label to optimize the entire neural network. And also like the input and the label are both, you know, one-hot vectors. That is means, for example, number 3, like it means number 3 dimension is 1. So that you have the one-hot vector as input, and also you have labels. And then what is the negative sampling? It means that, you know, basically, conceptually, you may think that you need to calculate the third layer, the entire third layer, so that you will calculate the loss between the output, the third layer, and the label vector, and to optimize the entire neural network. However, in practice, sometimes, you know, these vectors are pretty long, and also only one neuron is 1 and others are all zeros. So that means the most important neuron is that it is one which has a value 1. So this negative sampling is that like it trying to only sample a couple of neurons whose value is 0, just like that. If I specify the number of negative sampling at 2, then I just sample 2 neurons whose value are zeros. We call it negative samples here. So when we calculate the neural network and do the optimization, we only calculate this neuron with value 1 and this kind of sampled negative neurons, and we only optimize the entire neural network, this weight, according to this sampled sampled neuron, and we just ignore all of these gray ones. So in this way, we do not need to calculate the entire vector, the third vector. It just be really more efficient this time. So do you have any questions?
Yes. What does a negative sample represent? If I were to give a sentence and put it through the neural network.
It's actually you mean what does the negative sampling represent?
Oh, well, yeah, the negative sample. If I were to have a sentence, for instance, give a dog a bone, what would the negative sample be for any context of certain words, like just 2 words?
Yeah. First is that you it can be any word except for this one. You know that for this pair, you only have one true class, and the negative samples can be any word at the other dimension. It means other word.
I'm sorry, I'm still trying to grasp it. So just going back on the example, give a dog a bone. If I were to have an association between the 2 words, for instance, the negative sample would be like give and bone. The word give will be a negative sample.
The give and bone is the positive sample. It is not the negative sample. The negative sampling means that when you train the positive sample, you know that like the get is represented as the 1 hot vector, and the bone is represented as the 1 hot vector. So other places are all zeros, but when you calculate neural network, you have to calculate all of these values. This time we want to just to ignore these kind of values and only calculate these specific dimensions.
Specific dimensions, okay.
Yeah.
Because we have a list of words, for instance, depending on what text that we have, but the association of those words within a given sentence, that's when a negative sample and a positive sample will be differentiated?
Yes.
Okay.
And yeah, and next is that this is an example about how to generate some negative samples. And the example, we take a pair of target word and contact word here, and we specify the number of negative sampling as 4. And this is a seed because this is a random process. And here we just TensorFlow provide another API to sample some negative sampling like that. Here we present that here there are four negative samples selected, and these are the corresponding word it represents.
Makes sense.
Yeah, and another step is just to gather that together. You know that as we shown here, we have one positive sample pair, and we select several negative samples here. So we just want to gather them together, and this is what we did for just to combine them. And we will show them in the format of like a 3-element topper. One is, you know, the target. One is the target word is give, and this is the index. And then there are 1, 2, 3, 4, 5 words in total. And the first one is the positive sample, which means this is a neighbor of give. So we just specify the label is 1, and all the others are we randomly selected word, and the labels are just
so the randomly selected. Oh, okay, they're randomly selected.
Yeah, random selected, and all the labels are zeros, just like here. You know, that's straightforward. We may need the vector like the input vector like that, and output vector like that. And currently, we just select some of the neurons. Yeah, and this time, each training sample constitute of these 3 elements. We call it, you know, target, just like in that form.
Gotcha.
Yeah, this is the target, and these are 1 positive samples and several randomly selected negative sample. And the positive samples has the label 1, and negative samples have the label 0. And the reason why we represent in that way rather than just the 2 vectors, because you know the 2 vectors are too long and you have many zeros. It will cause it will cost a lot of memory, and so that we just finish the data preparation. And next, this is the example for one sentence. So we just aggregate all these step-by-step themes together here as a generate training data method, and just to apply this method to our entire data set. And here, within this method, besides these steps, there is one more steps at the first place, which is called like sampling table. This technique is actually what we call about subsampling, and this is an example. Subsampling is just like TensorFlow provides an API, and you just specify a number. This number is the size of the vocabulary. Then it will it will provide you like a list of probabilities, and that probabilities just used to, for example, this probabilities specify like the probability to remove a word. And for example, like in a text corpus, there are some words appear too many times, and for example, like the word a or the THE. I mean, so because they appear too many times, so actually the information delivered by Jupyter are very few. So they just want to remove some to reduce the frequency of that kind of frequent word. So that kind of sampling, called subsampling, just you automatically generate some probability, and the more frequent this word is, and the higher probability this word to be removed, like that. Then you just apply the sampling table to every word in this word corpus. For example, like the word THE, when maybe there is like a 10% probability to remove this word. And after you did the subsampling, and all of the steps are what we showed for each sentence, we just generate the training samples. Do you have any questions about the subsampling?
So subsampling is what, generating the probabilities, or?
Yes, just the probabilities. And these probabilities is used to give a chance to remove some frequent word in your text corpus.
But it has nothing with the technique itself. Like it has nothing to do with skip track or whatever.
Yeah. But in practice, the experiment shows that when you remove some frequent word, and the quality is better.
Okay, makes sense.
Yeah. And so what we did is just to apply this method, this function, generate training data to all of the sequence here. You know, we have like more than 30,000 sequences, and they need to process them, all of them. I don't know why it seems runs much slower than yesterday.
So in the meantime, how's everyone's week going?
And later on, yeah, when there is time for screenshots for their assignments, and could you remind them, you know, say this is a time, this is a place where, you know, you need to take screenshots. So
yes, here you can see all of these sequences have been processed and generate these three elements: the target and the contact and labels. And the number of the training samples are like around more than 60,000. And let's get some sense about what it looks like. Here I just print the first 5 of these pairs, the training samples. And the first one, you can see the target. This is a target number. the index of the target word. And here is a tensor, actually just a vector. There are 5 other the contact word. And the third element is a label vector, means the first one is the positive samples, and the others are all the negative samples. So next we will move to how to implement Word2Vec. So basically, this block is all the code we need to define a Word2Vec neural network. And it is provided by TensorFlow 2 version 2. If you are using version 1, you may need other APIs. And this API actually is provided by Keras, and Keras has a model class, and we just need to inherit the model class, create a subclass of model, so that there are many built-in functionalities. And what we need to do is just to override 2 methods. One is init and the other is core. And the init is we just need to define what kind of layers, what kind of operations within the Word2Vec model. And the core is like we specify how to calculate, how to compute based on these kind of layers from the input to output. But that this version of implementation is a little confusing because it is a little different from the conceptual implementation here. Since I think we have enough time, so I can explain a little bit about this implementation. You can see that the Word2Vec, what the Word2Vec did is just a 3-layer transaction. Like we have the first layer, and the first layer multiply the weight matrix, and then we got the hidden layer, and the hidden layer multiply the second matrix, and maybe add then call some activation function, we got the third layer. So however, the implementation of Word2Vec is not as that way. So basically the implementation, if you want to check a little bit, you can see here there are two embedding layer. The embedding layer are provided by TensorFlow. They are actually two weight matrix, just like the W1 and W2. And you can specify the shape of this embedding matrix by here. You know, the shape is the vocabulary size multiply the embedding dimension here. You can just specify here, just like the length of the I cannot move. Sorry. The length of the first layer and the length of the second layer. And however, the computation is not like the PAL is the data input, and we first get the target and the content from the PAL. However, the computation is not like we multiply the targets with the first matrix and then multiply the second matrix. What it just did is just to first to feed this. This is actually this API is actually a lookup operation, which just look up the number of targets vector of the entire embedding. And this is actually, I just draw a small visualization to give you some intuition like that, why it's implemented is like that. Because what we want to do is to use this vector and to multiply the entire weight matrix. However, because this vector is a one-hot vector, so actually what happened is here is that the result vector is exact like the lookup operation. Although what we what we do here is just a matrix multiplication, but because one of this vector is one hot vector, so the effect is just like lookup. So here, this one we just use a lookup operation to directly look up the vector here as the WE, and for the CE is
I have a quick question, if you don't mind. So if the embedding underscore dim, is that the dimension of the number of features that are?
Yes, the embedding, embedding actually are the hidden vector here, which means the embedding is just this vector, but this vector actually is just one row of this matrix.
Oh, okay. So this is the features that are for.
Yeah, you can treat it as features, because like we have it before. We have some numbers, like this 982. The 982 will be represented as a one hot vector that's only the number 982 dimension is 1, like just like features, and other places are all 0.
Okay, all right. Thank
you. So yeah, let's continue that. So for the real implementation, the first operation its runs is a lookup, just a lookup this row, and the second one is still a lookup. What it is looking up is to look up one of these vector from the second matrix, and the third operation is just a dot product to calculate between the first embedding and the second vector. That may a little bit confusing here, so we just give you an intuition that is conceptually conceptually the like how Word2Vec works is like that, from the layer 1 to layer 2 and then to layer 3. But actually what it happened is just to use two lookup operations and then call a dot product between these vectors, because actually we only need to calculate one neuron. If we want to calculate the entire layer, we may need this vector to multiply the entire matrix. But because we only want one neuron, so here just the two vectors to multiply together. In this way, the implementation could be even more efficient. And do you have any question? I know it is a little confusing here, and I think you can ignore it because all of them are mathematics. And the takeaway message is that the implementation, actually, they have some design to speed up the neural network computation. And no questions, then we will continue. And this is the network model, which just specify how to calculate the output from the input. And next is that we can just generate an instance, which is by running the init method to give the vocabulary size and also to give the embedding dimension. Here we use 128. Here you can also feed other values, any values you like, and we need to call the compare method to just build a model. And when we build it, we need to give it specify some arguments, like what kind of loss function you are use and what kind of optimizer you are use. Basically, you can treat this compare as like how to do the backward propagation. As we said that when we build the neural network, we specify how to calculate the output, this is forward propagation. And by calling the compile, we just specify how to do the backward propagation by give them what kind of loss you want to use and what kind of optimizer you want to use and what kind of metrics you want to show. So these models are already configured. The next step is just to combine the data and the model to train the entire model. We need to give them a little some hyperparameter for training. For example, the batch size and like the buffer size, which is used by this API, the dataset set API. And generally, like if I specify this batch size, it means that it will split the data as several batches and train them one batch by one batch. And here, it's also TensorFlow provides some APIs to speed up the training, like the cache and the prefetch, like that. And you can see finally the data set, the shape of the data set looks like that. This is the shape of the target word because we have 124 samples. And this is the shape of the contact word. And each one, as we said, it has 5 words here. And the last one is the label vector. You know, just one of them is labeled as 1, and others are all negative samples labeled as 0. And then we can start training. Training just call the fit method to pass the data set in, and you can specify how many epochs you want to run, and then it will show the training logs like that. And when you do the experiment, you need to take a screenshots on the log output from the model. Is there any questions until now? No.
I have just a question for Dr. Yao. Is the video going to be available after the lecture right away?
Yeah. I want to. I think the easiest will be put it on YouTube if you all don't mind, because your videos are showing on there. So if you don't mind, then I'll put it on YouTube. If you don't want your faces to be there, then let me know and we can post it on Canvas. Yeah.
I mean, it's going to be available today, I mean, so that we can review it.
I'll do it right away.
Thank you very much.
And after we training these epochs, there is an interface for us to visualize these logs and accuracy. We just need to run this command, TensorBoard. But remember, if you want to use TensorBoard, you need to call the TensorBoard callback before you training it, and to give it a location to store some logs. And then TensorBoard will run at this kind of logs. I can show you how TensorBoard work. I just run this command here, and the TensorBoard the directory for logs, and then it will show it's pretty slow. Sorry. Yeah, it gives you the URL that you can copy and paste in your browser to open that. Sorry. Copy paste here. And then you will show the TensorBoard visualization about the accuracy along the epochs during training, and also the loss decrease during training. And there is a smoothing parameter you can use if there is no smoothing. Like this is our logs the real values about the change of the accuracy and the loss, but it provides us smoothing parameters so that you can get a more smooth one to look about the trend. And here, that is just the finally step. That is, we already get the embeddings. As we said, the embeddings are actually this matrix, the weight 1. So we need to get the weight 1 out and store it. Here, you can just call the model get layer method, and this is the name of this layer, so that you can get the weight for this layer, and next to store this weight in your computer. Here we already get the weight, and then we just store the weight. Here we store two files. One is vectors to store the weight. Another one is called metadata to store all of these vocabularies.
Oh yeah, I just have a question in regards to TensorBoard. Could you go back to the command back on your terminal?
Yeah, this one. Just a TensorBoard and give a flag about the log directory.
Okay, and it would just pinpoint you to a local host and then just put that in your browser.
Yes.
Yeah, well, yeah, just following, trying to get the command. All right, okay. Thank you.
And we just talk about store all of these weights in our computer. Let me check. Let me check my version.
We don't have to worry about this on Google CoLab.
Sorry, what about Google CoLab?
I mean, Google CoLab, will we also have to specify directories in that way?
If you are doing the experiment in the Google CoLab, you may need to download from the Google CoLab to your local machine. Otherwise, the next time when you connect with it, I guess it will disappear. I didn't try.
Oh, okay, yeah. So
these are two files. One is the metadata is just it's just a list of vocabularies, and the vectors are all of these weights, and each row is a vector representation of the corresponding row of the word. So do you have any question about it? So that if you want to use it, you just need to load the entire matrix and to load this one and found its index and use the index to retrieve like its vectors. Any questions? I guess no questions. No, I think the most difficult parts for understanding is just the neural network, the calculation, the neural network implementation. Yeah. But you don't need to care about the details.
All right.
So the implementation itself does all the backward propagation and everything inside of it. I don't really care about any of that.
The implementation, you can just copy and paste because it provides this implementation for you. Like if you just want to implement Word2Vec, you just copy and paste these a few lines. But if you want to say you have some idea to customize a Word2Vec, for example, if you want to add another layer, you want to add another layer in the middle, so that you need to write by yourself.
I won't do that, thank you.
Basically, actually, I think it just leverage the multiplication between the matrix, and it just reduce the multiplication as to lookup and one dot product. like that. And the reason why they can do that is the first multiplication, it is a one hot vector. So actually it is a lookup. And the second one is that because after the negative sampling, you only want to calculate the neuron, the value of one neuron instead of the entire vector. So you just need to look up a vector and just multiply two vectors.
All right. So any other thoughts? Yeah, any good sources that they could use? Did you know, when you first started learning neural network, anything that you find useful?
I think just the website of this tutorial, it also includes many other libraries. We can just directly use it. I know that it looks like that kind of implementation is difficult, but actually you just need to use it. You don't need to change it. So just copy and paste.
Yeah. All right. Gunnar?
I'm trying to get to the I'm trying to get to the Google Tensor board, but I'm running the commands and copying and pasting it, but it's saying that Word2Vec tutorial is not recognized or external command. And so I wouldn't have any issues if I were to do this through Google CoLab.
So have you tracked your logs already in the correct directory? I mean,
the logs in the correct directory.
Yeah.
Because I did everything through Jupyter Notebook, but if I wanted to do this on, because I already went through the whole process along the way, but I'm sorry, I'm kind of lost.
So you are running on your local machine or in the CoLab local machine?
Yes, local machine.
And what kind of error message it gives you when you're trying to pop up the window?
Hang on, I'm sorry, I'm doing this on my desktop, so I cannot really share. But it's saying that because what I did was going back on your terminal, I would type in the file Word2Vec _tutorial, and then the percentage tensorboard -- log dir equals logs. So it's the last command going down.
So actually you just need like, I think this is exact the command from.
Yes, that's what I'm implementing. But the problem is that when I set up on my local machine and put in Word2Vec tutorial, it's saying it's not recognized as an internal or external command, because I just start off with the file name.
Maybe if you checked the directory, like if you checked here, the logs are already in your disk, then you can check about the tensor board, like whether there are specific configuration tensor board needs. I guess maybe you can check.
How did you get to the log? Well, because all I did was go through the file and just downloaded the whole file from Google CoLab. So how did you get the log files? I understand it's through the tutorial.
The log files will be automatically generated and saved if there is a TensorFlow callback. We specify the logs directory and we pass the TensorFlow callback here when we run the method fit. So this will tell the model to.
Okay, no, I see it. Okay, yeah, I see him. I see the train logs. Yes. Okay, yeah, there we go. Yeah, it's on my desktop actually.
Okay, excellent. Right. Any other questions for now? And I just extended the due date to Friday midnight, and so that gives you guys more time to work on the lab report. And also I took the liberty of giving Ya's email address to the students. So if you have questions, email, let her know. So any questions? So and I do want to make sure that you all get familiar with this, because we're gonna do it a different tutorial on Monday. So this is very important that you get yourself familiar with this. Oh, good. All right then. All right then. Then I think we can stop